All right, so let's start. I left some messages in the chat. So if you want to ask a question, please feel free to use the Q&A tab. You can click it on the bottom of the webinar. I'll be looking at them most at the end. And please try to give context on where's the question, because at the end, I may not be able to remember which place exactly was the question made, which slide I was sharing. But feel free to ping me in the chat. Also, if there's any issues, like you stop hearing me or stop seeing the screen, let me know in the chat. I will keep the chat open here to monitor anything. So let's get started. And also, I saw someone asking, the event is recorded and it will be shared in about a week after today. Great. So let me start here. So to begin, let me briefly talk a bit about me. So yeah, this is my family, my lovely wife, my son. This picture is a bit old now. It's more than 2 years, but it's more or less when we arrived in the UK. So that's why I chose this picture. So we are Brazilians, and I've been living in the UK for a bit more than 2 years now. Two things I love to do, so games, playing games and traveling. Well, I can't say I have been playing many games lately, but well, at least I've been catching up with traveling to places that I didn't know. And currently, I'm a software engineer at Meta. I've been working I've worked for different companies in the past 14 years, and in the past 2 years, I'm working for Meta. So yeah, brief outline of what we are going to talk about today. First, let's just discuss why we would do this test in production. What's this crazy thing? Then we'll briefly discuss some metric topics. Then we'll land on how to actually do it safely, how to test in production in a safe way, land the code directly to production, and finally we'll wrap up with something. Also, please let me know if I start speaking too fast. I will try to slow it down. Sometimes I forget that I may start talking too quickly. So yeah. So, well, okay, why would we test in production? Why would we want, in the middle of the fire that we are fighting or some chaos that's happening, why would we want to add some more problems to us? Well, stay with me for a moment and we'll discuss that. So, well, there are two angles that I would like to bring today. The first one is because, well, sometimes we have to, sometimes we don't have options. Sometimes the staging environment doesn't exist. And by staging here, I'm calling anything that you could use to test before production, and it's not your local environment. Okay. Sometimes the staging environment exists, but it's unreliable. So you have maybe a bunch of services, microservices that depend on each other, and every time you want to run one, you have to see if the others are in sync, and etc. Maybe it's because it's too hard to reproduce real life data, and you can't rely on the environment because of data. Maybe because we have environment dependent issues. You know, those bugs that only happen in production. Sometimes we have to go and try to test something direct in production and then something almost blind. Great. Another slice, so is because we may want to actually. So, well, production is closer to what users will experience, and that's one good reason to test software in production. Slide. Okay, let me try to string. Thanks for the feedback, John. Let me see if I can sort this. Is it better? Doesn't look like. Let me reshare the screen. I think I may know what's the problem. But just let me just reshare the screen. Give me 1 minute. Okay, is it better now? Great, thank you. Thanks for the feedback. Thanks for saying that. All right, so let me just see if nothing broke here. Okay, seems that everything's working. Thanks again, John. So where were we? Okay, yeah. So sometimes we want to test in production, so it's closer to what users will experience. We have real life data, real life scenarios, and well, that may make things easier to test. We have production volume, production traffic. For some things, we don't need it, but sometimes that's very handy. Let's say, for example, you are testing a new API and you want to see if it holds the scale of production. And well, it gives us a shorter release cycle. So if we can skip some staging and earlier tests, we can maybe ship software faster. With that, we can get earlier feedback from users, from data, from monitoring, from whatever. And that could give us a good advantage of faster product iteration. So this is not the main topic. I just wanted to touch why we would do testing in production, ship things directly to production. Before moving, just a disclaimer. Please be mindful about security, privacy, regulations, and the risk of impacts for any failures that may happen. So while we are discussing testing things in production, it's not obviously not the intention to, for example, leak user data because we are accessing production in a way that we shouldn't be accessed. So all those measures should be protected and keep in mind the regulations that affect the business we work for. Great. So moving on to the next topic, let's understand what's the baseline for using the production environment for shipping software. Let's get the scenario of changing a button. Okay, looks quite simple, easy, straightforward. But what if it's the checkout button? Maybe the button clicks drop by 10% because of what we changed. I mean, we should be mindful of that. But what does 10% mean? What button clicks mean? Does it mean that less users are buying? Are our sales dropping by 10%, for example? That would be a disaster for any company. Well, so we need to have metrics in mind anytime we do changes to our products. So one question, what are we trying to improve? I could think of a few things. So it could be KPIs, goals, user behavior, some things that are valued by the company, metrics that drive the company forward. But it could also be, I don't know, some technical things like the response time, the error rate, machine capacity. All of those are metrics. All of those are valid metrics. And we need to understand what are we trying to improve. Sometimes we may even not be trying to improve something. We just want to, I don't know, ship a different experience, do a new branding, but even so, we want to understand what are the guardrails. We want to understand what we don't want to break. So in that particular case of the button, if the button clicks in the checkout page of an online shop, we definitely don't want the click rate to go down by a certain margin or above a certain margin. So without metrics, we are blind. So that's why it's so important to understand the metrics and to follow the metrics, be able to monitor them. Okay, but we have metrics. Let's assume we have some metrics. It was defined by the company, by the engineers, etc. How can we ship our software safely? Well, the first and obvious way. First, don't forget the basics. We have to validate the change as well, of course. We have to understand that what we did works. Even if it works on my machine, it needs to work. We can use automated tests. We should use automated tests. I'm a big fan of that. I would always push to using more automated tests, but sometimes we also have to use manual tests. But the important message is that don't forget the basics, and overconfidence is dangerous. If we forget to do the basics, it could go bad, and we don't want to do that if it's going directly to production. The second topic is monitoring. Well, we have the metrics. We have business metrics. We have technical metrics. What can we do? How can we use those metrics? So there are a few ways. First, we can set up alerts. Let's say, for example, using the same example of the button, the checkout button. If the clicks dropped by 10%, 5%, 2%, it could raise an alert. It could send you an email, a Slack, any tool that's used in the company. We can also have dashboards, so active monitoring. I've worked in companies that have, for example, a team focused on monitoring. And for that, they need dashboards. So we can have dashboards that we look, for example, daily, weekly, monthly trends, what's going on, and spot some spikes, some unusual movements in the metrics that we wouldn't expect to be happening. And then we can mention many other things. We could use logs, and by logs here, it could be text logs, database-based logs, any logs, queries, jobs, etc. So there are plenty of ways to monitor, and we need to monitor. That's the base of any change, anything that we are shipping. And yeah, so now we'll move to a few like DevOps practices that could also help us, and then we'll move forward. So the first one is Canary release. I believe many of you have already heard about it. In short, what does it mean? So it's a gradual rollout. So instead of shipping everything at once, you do it gradually. Usually begins with no more than 10%. I've seen it as small, like 1% or smaller, sometimes 10%. But the idea is you ship the changes to a subset of your clusters, containers, servers. You validate what's happening, you monitor the new version, and then you increase the rollout if everything is okay. Sometimes you can do it at once. Again, sometimes you can do it like from 10% to 20%, then to 50, then to 100. But in any case, that's the process of doing. So how does it happen? So before the rollout, we have, let's say, a load balancer with a few containers. And during the rollout, you change the version of one of the containers and put like V2 there, for example. And you monitor it, you check that everything is all right, again, based on the metrics, based on the monitorings that are in place. And after the rollout, everything would look like this. So V2 is there. Oh, what happens if a problem happens? What if a problem happens? Let's say you start the rollout and you detect a problem. You can roll it back. So we go back to this stage and investigate the issue, find the bug, fix it, and begin again. It would be a V3 and try until we get it rolled out. So this is a good strategy to mitigate the impact. It won't be zero, but instead of breaking for 100% of the users, it could be breaking for, I don't know, 1%. Another one that's usually discussed in parallel with this one is blue-green deployment. So what's blue-green deployment? Basically, we have two production clusters, blue and green. Blue is the one considered to have production traffic, and green is the one that will be receiving the new version. What we do is that we deploy the new version in the green one, we validate the version. That could be through QA process with, it could be, for example, by pointing specific users to that. There are some ways to do that. After validating the version, we switch the traffic to the green cluster and continue monitoring the release. So after the release is changed, if there's any issue, we can also roll back. The good thing is that the blue and the green clusters, they are kept for some time. So let's say, for example, this is how it looked before the rollout. We put V2 in the green cluster, and we switch it to switch the production traffic to it. If there's any issue, we can switch it back. It's very easy and almost no downtime usually. So that's one of the advantages of blue-green deployment, to also minimize the impact if anything happens. So these are mostly related to usually like full artifacts, deploying a version, let's say a backend version or something like that, or let's say an app version in App Store. You can choose like some gradual rollout. Now we'll go one step deeper and start talking about some application controls that we could also use. So the first one is kill switches. And to understand kill switches, we need to go outside of software for a bit and understand where they came from. So in industry, in heavy machinery, sometimes you have accidents, and accidents in these contexts can be quite dangerous. It can be life-threatening. And kill switches are there to ensure there's a way to very quickly and very simply stop a problem in an emergency and stop it in a way that it will halt immediately. And the reasoning is that it's better to break the machine than to let it continue and stop normally. So that's where kill switches come from. And when we bring this back to software, kill switches are very useful. Let's say we launch a feature and then we realize, hey, actually, there's a critical bug there. And this critical bug is so bad that we need to revert a version. But if you have a kill switch, you can simply disable that feature and allow it to the software to continue, the application to continue working without that feature. Sometimes it could be useful, for example, for high load scenarios. So I saw some cases in the past where we were under heavy load for particular reasons, and we needed to disable one or two features within an app because we wanted the users to keep using it even without a few features. So it's better to have some users able to do something than no users using it at all. And of course, it's a special case of feature flags, feature toggles. There are different names for that. And one thing that I like about kill switches or feature flags is that they allow the code to be safely published. So you can even like put it directly in production, disabled, and it should theoretically have no impact. So one very, very high level simple implementation. Let's say, for example, you can have this. So if, let's say this is the call for the kill switch feature is enabled. You have that feature, you call the new behavior. And if you disable the feature, that line of code is never invoked. Of course, you could apply this to more complex scenarios. Not all, it won't be always that easy, but just to give an idea of a very simple way to do it. And well, two caveats here. First, the software needs to be able to process, to continue without that feature. If it's the most critical part of the request, it will break anyways. So it has to be built with that in mind. And second, well, if we have, for example, a new version of something, you could also have something like that. So if you are enable the feature X, you use the new behavior, otherwise you fall back to the old behavior. And well, looking at this particular example, I would also like to touch one topic that, well, as an engineer, I know how it could be hard for some people. What about the old code? How long will this keep there? So, well, it's okay to keep it live for some time. It can reduce the impact if rollbacks needed. But let's just remember that after some time, this X old behavior call is probably unreliable and should be removed. So we need to understand the tech debts, understand when a feature was replaced to avoid breaking the software even more. Let's say, for example, this change was made 2 years ago and you identify a new bug in this feature and you want to stop it. I would guess that the old version of the feature is not working. It's probably going to break even more than the new version of the feature. Just 1 minute. Sorry. Well, going now to the next part, it's, I guess, my favorite one. Shadow testing, also known as dark mode, dark testing, and some other names. So what does it mean? So we have, let's say we have two behaviors in the software, the current and the new one. And notice that I'm not talking about versions necessarily. It could be applied to a whole new version, but it could also be applied to a very specific part. We'll get to that. So in shadow testing, we have, let's say, two code paths, and you execute both, compare the outputs of what happened. We discard the new behavior. So we just run it to compare the outputs and return only the current output or use it only the current one. So this is a visualization of what would this look like. One question, can you, I don't know if you can see my pointer here. I will assume you can, but I'll try also to, okay, thanks John for confirming. So an abstract system here. So we have a production flow happening here, the system, let's say at some point we want to call the green component here, the current component. So this is how the production request would happen, and the production response would come back and resume giving an answer or response to the user or what would be expected. With shadow testing, what we do is, well, we continue doing that and using the reproduction response, but we also do a shadow request for a new version of that green component. And this shadow response is used to compare the difference from the production response here. And please note that we don't use this response here to enforce anything or to affect anything the user sees, but the behavior was run in production, and that's the biggest win we have here. So, sorry, just going back. So there are a few things I would like to highlight here. So first is that we are running in production. So we are able to test with production traffic. We are able to test with inputs that happen for production. So What are some use cases of that? Well, various. I think this can be applied to almost any change of almost any level, but just to give some examples, we have, for example, backend migrations. Let's say you want to switch server or version of something, or do a like full migration to one application server to another. Well, we can use that. I will leave in the slide some examples, but we have some tools to help with those kind of comparison between the server logs and etc. We have performance tests, as I mentioned. We have production traffic. Of course, it needs some tuning here and there. We can't simply let things run exactly as in production sometimes, but it allows us to be as close as possible to running in production without affecting the user. And this is, I think, what I like most about shadow testing. It, if done well, if implemented correctly, it won't affect the user. So the user won't see any difference. It's all done in the background. Another example, switching API service providers. Let's say, for example, you have an email provider that you use to send mailing for your company, notifying users of new features or something like that. And you want to switch to a new one, but you don't know yet if it's gonna hold or something like that. If the service provider allows, for example, to just invoke the API without actually sending the emails, you could just route and use that traffic to see if they can handle the volume, if they can, for example, attend to the peak volumes of levels, etc. Or maybe we want just to upgrade internal features of the system and even small features. Sometimes I notice that I've been using this so much lately that it's almost like my new way of working. Sometimes I get like to a particular part of the code base that I have never touched. I have no idea what impacts it could cause. So I make a change, I put it under a flag or something, I do it as a shadow mode, compare with other behaviors, put some logs, and let it run in production and see what the logs, what the information is telling me. And well, that's very, very useful. Well, just to close this part, what are the benefits? I've mentioned some, but just to be very explicit. So first, production scale. So we have full scenarios, real life data. We have users behaving as users. The problem with tests is that we are always biased. I've worked with companies that the engineers are the only ones that do tests. I've worked in companies where we have dedicated QAs. I've worked where we have QAs that pass test plans to engineers, external QAs, partners, other companies, and in all of them, the testing scenarios are very limited compared to what users do. Users always find weird ways or new ways, let's put it that way, to do things. And well, minimum risk of impact. Of course, it's not zero risk, especially if it's not implemented properly. But well, it can be quite easy to use. Of course, doing a full server migration and implementing the tools will be more complex than applying to just a particular function or a new endpoint. But just to give a very high level idea, especially if you have never heard about it or used it, this is a sample. So let's say, sorry about if I don't know if the image is very clear, but let's say we have a code running here and we want, and at some point, it invokes a math library to sum two numbers. Yeah, basic first grade example. And we please note here that we get the current result and we return it at the end. And the current result is sent to the company responsible to do that. So here we could do a bunch of different things. We could, for example, put the new sum under a feature flag or a kill switch. We could surround the new call with try catch. I didn't put it here because it would get too complex, but we could, for example, make this a sync call and don't hold the user request and many things. So, but basically the idea is, well, we invoke the new math library, we do the sum, store the result, we log this, and how to log this is up to the system, up to the tools that you have, but most of the logging could be very simple here. And if there's any divergence, we start. So one technique I use here, for example, is instead of logging very complex things, sometimes I just want to know like if the result is as expected or different. So I just log equals or different, and with using a specific tag, just like a key value, and it's summing whatever it happens, and then I can see if the divergence is significant compared to the values that are equal. So this is shadow testing. And late, we also can talk about dogfooding. So I already mentioned how biased our testing is, but it's still valid. So yeah, why not? We can use internal testing in production. And this is particularly interesting because we still have the same code, the same infra of final users, but so we are able to test it in the real infra without affecting users. There are some ways to do that. So we can, for example, in some scenarios, we are able to have test accounts. So you can create test accounts in the database, you can use them, isolate a bit, sometimes not. Sometimes you have to use real accounts. It depends on the business. On some sites, I remember once I worked in a company that we weren't allowed by some regulations to have fake or test accounts in production. So we either had a staging environment or we used our own production accounts. We also have a difference. For example, sometimes we can dog food the whole artifact. So one example that comes to my mind is in mobile, both Google App Store and Google Play Store and App Store. They allow you to upload the version and enable that particular artifact for just some users, internal or external. Sometimes we can do it by permission, by features. There are many, many tools that do that too. So yeah, I hope this helped to give some ideas. Feel free to start posting questions in the Q&A. I will start wrapping up in a minute. So what did we discuss and see today? So first, well, we talked a bit about metrics. We understood how fundamental they are and how we need to monitor with various ways, tools. We also looked at some DevOps practices and tools like Canary release, blue-green deployment. Then we moved some application level strategies with some code examples about feature flags, kill switches, shadow testing. And well, maybe we also learned that testing production can be a good idea. I hope I contributed a bit to on this topic to you. As I promised, I left some additional resources, especially some tools for kill switches, feature toggles, and shadow testing that are usually a bit less known. And yeah, I will give some time for QA. We still have a couple of minutes, so I will wait a bit to see if there's any questions. All right, I didn't see any questions. Let me see if there's anything here. Okay, I will give one last minute in case someone is typing anything. Otherwise, we'll close the session. Again, thanks everyone for joining. Thanks for the participation, jumping in on the chat to tell me about what wasn't going well. And yeah, thank you very much. So I will close the room right now. Please let me know and feel free to reach me out on my socials. I left also some of them here. So feel free to reach me out. Thank you. Thank you, everyone. See you in the next time.